Hey guys, I'm Cyborg Sheep, and welcome to the Weekend Post. In this episode, we're going to be doing something a little different. If you remember in the past, I built a hydraulic robotic arm, and it's been holding up really good. The one thing that has broken on it is the little hand crank that turns the base rotation, but other than that, it's been holding up pretty good. But a few years before that, I built this robotic arm right here. This has been holding up pretty good, but the one thing that has broken on it is the switches. If you remember online from maybe pictures or something that you saw, or maybe even videos, they'll have these little yellow levers right here. I took mine out because if you see right here, these switches break. Now, I knew these were gonna break right from the very start of building this. So, what I've been thinking for like a few months now, that I should modify this robot arm, change the switches, and make it wall powered. So, let's get into this video. So, as you guys can see, if I take one of the little metal switch pieces and I bridge the gap, all of these axes right here work just fine. So all that really needs to be done is to change these switches with some actual better functioning ones. So, like I said at the beginning of the video, I not only want to change the switches, but I also want to make it wall powered DC by an adapter. Now, a characteristic of these motors is not only the volts that they want, but also the amps that they want. And for motors like this, I wouldn't expect them to draw any more than an amp per motor, but we should check that just to be sure. So, to check it, we're going to take our multimeter, and we're going to put the red probe in the 10 amp socket, and we're going to put the black probe in the common socket. And what that allows us to do is to measure the amp draw of these motors. So if we set our multimeter to 10 amps, and we do exactly what we did with the metal piece right here, the metal switch, this guy, and we take the probes and we put them across where we put the metal piece. If you watch this display here, you can see the amp draw. So, for that motor, 2 amps. Let's try the other way. 2 to 1 amp. That one's around 4 amp. 2 amps. Around 1 to 2 amps, unless you stall it. And for this motor, 2 amps. So, now what I would do is take the highest amp draw of all the motors, which is 4 amps, and times it by the 5 motors. So, 4 amps times 5 motors is 20 amps. Now, that's a totally unrealistic value. You're never going to find an adapter that supplies you with 20 amps. For context, a normal wall socket has a 50 amp rating. So, if you even try to hook it up to that, you're going to pop the breaker every time. So, a conservative way to think of it is, how many motors do I want on at a time? I'm going to say I only want 2 motors on at a time. So, a good way to think about it is 4 times 2 equals 80 amps. So we're going to look for an adapter that has an 8 amp rating. This bag right here contains all the parts I need. A DC input, a DC plug, 5 switches, a DC power cord, a power supply, plus a case for it. Alright, now in one of my previous shots, I said to you that there's no such thing as 20 amp power supplies. I'm going to correct myself now and say that that is completely wrong. Of course there's 20 amp power supplies. There's 32 amp power supplies. Never mind that. This is a 15 amp power supply, and it doesn't pop the breaker because there's a transformer in here which, one, steps down the voltage from, say, 120 volts down to 12 volts, and in doing that, it also isolates it from the circuit breaker. So, no popping the breaker with 2 high amperage power supplies. It works perfectly fine, and when we wire it up, we'll see how it works. But anyways, I also got a case for it because the power supply itself, as you can see, it's just bare components. There's no case on it. So yeah, I guess we're ready to start putting stuff together.